so I'm going to go back to Python. I'm going to create a new script, and I'm breaking up this implementation to a few different scripts that do specific things. And this is a very good way to work in general. Start to break up your process so you're not working with one huge script into chunks. And this is for two reasons. One is that some of these things take a lot of time, so every time you troubleshoot something, you don't want to rerun through all this lengthy process. And another reason is you can start to develop your programs in a modular way, where certain things that do certain operations you can then reuse in new applications. Okay, so my next script is going to actually prepare the data for the machine learning training algorithm. Okay, so I'm going to save that as and call it to. And this is going to be called generate data. Okay, so for now I have data about words, about strings, but I actually want to prepare a structured data set that I can feed into my machine learning algorithm. Okay, so the first thing I have to do is, as always, specify my working directory. So I'm just going to start copying and pasting some common things from my first script. That sets up my working directory. I'm going to import the Pickle and the random libraries, which I will use again. And now I want to import all the 5 data sets that I exported in the last one. Okay, so this is also very common. At the end of one script, you export out the data you'll need in the future. At the beginning of the next script, you import all of that data. Okay, so one way to do this is I can copy and paste this here, just so I remember what I'm trying to import. Obviously, the syntax will be different. To load Pickle files, you have to set a variable that that file loads into. So I'm just going to keep this the same variable. And then the function is load, pickle.load. And then here I just have to specify one parameter, which is opening the actual file where it was stored. In this case, it's the same, right? So this is the benefit of kind of having everything consistent. And then here I just, instead of write, I want to specify that I want to read from the file. I can go through and make those changes for each of these files. Okay, so now I loaded in all my files and I can start writing the code to actually generate my machine learning data set. So as before, as like with the regression example, I'm going to have 2 basic lists. I'm going to start with them as just regular Python arrays, which are pretty easy to work with. And then at some point I'm going to convert them to NumPy arrays that I can use with the scikit-learn library. The next thing I'm going to do is actually shuffle both of those lists of words. And this is just kind of common best practices. When I was saving out those words, it was going place by place, right? First it would save all of the comments from one location and then all of the ones from the other. And as I start to do this, I'm going to want to break up these comments into training and validation sets. I want to make sure that I have a random sampling in those sets. Okay, so I don't want to keep all the comments from one place all in the same place in the array. So I'm just going to, at the very beginning, shuffle both the target text list and the not target text list. So the next thing I want to do is actually generate my data set. And I want to take equal amount of words from both of these lists. So I have a certain amount of comments that were in the target list, and I have a certain amount of comments that are in the not target list. And when I'm developing this training set, I want to have an equal amount of comments that came from OCT and comments that came from outside of OCT, so I have a pretty even kind of machine learning training process. Okay, the problem here is, as you remember, I only had 36 locations in OCT, in this OCT data set, but I was taking 5% of all of the comments from everywhere else. Okay, so it's a really disbalanced set right now. Just to see what that means, we can just run this very quickly. Make sure you've changed your function names. I'm going to run this basically just to load all these files. I haven't really done anything yet, but now we can look at the length of these 2 sets of comments. Okay, so there's 4,000 comments in the OCT set, but there's 240,000 comments in the other set. So if I build up an entire training set, taking all the comments, it's really going to have a lot more comments here, and it's going to make a disbalanced training situation. And the rule of thumb in supervised learning is the more you can have the same number of training data points in all of your categories, generally the more efficient and more accurate your training model is going to be. So knowing that I have 4,000 comments here, I'm actually going to limit the amount of data I take from each set to 4,000. So that's another reason why shuffling is nice, because I'm actually going to only take a subset of comments from this set. Okay, so to create the loop, I'm going to say for text in text list target, and then here I'm going to subset the list and just take the first 4,000 comments. In this case, it's almost all of the comments from the OCT set. So now I want to start to populate these two sets of data. One is the feature set, which will be a two-dimensional array. In one dimension, it's going to be all of the comments as instances, and the other dimension is going to be all the features. Okay, so once I'm in each comment, I'm going to create an array called feature list. And this will hold all the features for each instance, each piece of text or comment. Now I'm going to create a variable to basically store my count of the frequency that each of these words occurs in that comment. Now I'm going to iterate through every word in each of these lists. Okay, so for word and in list, I'm going to start with a list of OCT only words. And I say if word is in the text, okay, so it's going to look for each word in that piece of text that I'm looking at right now. I'm going to increment this count variable by 1. And once it's ran through all the words in my in list, I'm going to add that count as a feature to this feature list variable. So as of now, it's going to go through every piece of every comment in the target text list. It's going to iterate through every word in the in list. It's going to count how many of those words are actually found in that comment, and it's going to add that as a feature of that instance, of that comment. Okay. Now I want to do the same exact thing for my other set of words. Okay, so I'm going to re-initialize the C variable. Now I want to look at my out list. And if that word is in that comment, I'm going to append that count again to the feature list. Okay. In this case, I'm not going to look at the both lists. You can try it both ways. There's nothing stopping you from having 3 features for each comment, but in this case, I'm only going to have 2 features. Okay. So for each comment, the features are going to be how many words from this set are in that comment, how many words from this set are in that comment. So 2 features. And then the target value, so this is the category of that instance, of that comment, is going to be 1, right? Because as I'm looking through this set, I know that all of these comments came from the OCT set. So I'm going to call up my target array and add the value 1. Okay, this is the category that all of these comments belong to. Okay, so this generates all the data for the comments inside OCT. Remember, this is 4,000 comments. And now I'm just going to copy and paste this whole structure and do the same exact thing for all of the comments that are in the set from outside OCT. Okay, so I'm just going to change some of these parameter names. Now I'm going to cycle through not target. I'm just going to take the first 4,000 out of the 250,000 that I have stored. Okay, so remember I shuffled these, so I'm taking a random sample. And I'm going to look again through both the in list and the out list, and then I'm going to count the number of times that those words appear in that comment. I'm adding it to the same big list of features. Okay, and I realize I forgot here, Here I'm just populating this local feature list. So this is the list of features for each comment. And actually, before I append to the target, I want to call up that feature array and add this local list of features. Okay, so this is where you're creating this two-dimensional array. So for each comment, you have an array of features, and then when you're done with that comment, you append that array of features to this bigger feature array. Okay, that's the two dimensions. I'm going to put that same line into the not target. And then the only difference here, as I'm looking through the comments outside OCT, is these are going to have the category of -1. So this will generate my basic data for my machine learning classification supervised learning algorithm. Basically, it's going to take all 8,000 comments, and it's going to train a system that, based on how many of these words from both of these lists exist in those comments, classify it as either 1, which means that the comment came from OCT, or -1, which means that the comment came from outside OCT. Okay, so that's all I want to do in this script, and at the end of it, I want to use Pickle to export both my features array and my target array out back into my file system, so I can call that up in the next script, which will actually train the machine learning model. Okay, so here's my code for exporting the Pickle files. Just make sure that the names of your variables match these data sets that we created, and export them out to matching data files in your system. So I'm going to run this. Okay, and if I go back to my data folder, now I have these two pieces of data created.